Okay, so yeah, we're good. Now it takes us to the phase shift. Now let's just remember what we talked about before. So this is going to look like this. Y is equals to a sine. Sine is this specific function that we're operating in here. So sine of b brackets x minus c plus d. We gotta be careful in here because now the b has to be factored out, and this becomes just x minus the c, just like what we did before. Okay, so the c is our horizontal translation. So that will determine if we're going to be moving it to the left or to the right. That's a main thing about that. That's the main job for that. Is it translating it to the left or to the right? And by how much? So we already remember what the sine looks like. We wanted to really remember. So sine function just kind of when we look at the sine function, it starts in the median. Okay, starts in the median at 0, and then maximum, and then that's the sine function. That's not a great one. Let me make it look like this one's slightly better. Okay, that's a sine function. Okay, what does a cosine function look like?
Take a big drop, a big rise.
It starts at the top. It starts at 1, maximum. Like that, right? Oh, not the best because it's not the same. Okay. So now what we're going to do is we're going to try to really kind of pick this up and then either shift it to the left or to the right. We're going to take this graph, shift it to the left and shift it to the right. Now, if this is going to be continuous on, right, we want to know, it kind of, like if it continues on, it's kind of hard to figure out if it got shifted to the left and to the right, but we'll figure it out in a second. So, over here. This is the first one. This is sine x minus pi half. This dashed, what do you think this is? That's the sine. That's the original. That's our parent graph, right? Now, and this one here is the pi half shifting, horizontal shifting. Did it shift to the left or did it shift to the right? Shift to the right. Okay, so that means every single point in here, so this point in here got shifted to the right by pi halves. Okay, this original point over here got shifted to the right pi halves. Okay, now this one, everything moved pi halves. And then this minimum here moved pi halves. So let's see here. if we have y equals the sine of x, what's the value of the c? 0, right? Yeah, because we can rewrite that as y is equals to sine of x minus 0. So our c is equals to 0. That means no phase shift. No phase shift. Okay. Did it move to the right? And it didn't move to the left. Here, what's the value of the c? Pi over 2. Okay, now, let's see here. Why is it pi over 2? Why is it not negative pi over 2? Well, yeah, how do we know that?
Negative's going to cancel out that positive anyway.
If it was negative, it'd be positive.
Yeah, because if it's a negative c, because if you take a look at this one, this is going to be always x minus c. So the c minus is already still there. The c is just the pi half. Okay? So this is going to be x minus c, and then the c is just the pi half. Okay, so pi half. And what does that mean? What's kind of description of that?
Shift right.
Shift
Pi half.
right by pi half. Okay. What about this one?
Negative pi fifths.
C is equals to negative pi over 4. And we know that because it's going to be minus negative sine of x minus negative 4. It just appears to us as a positive 4 because it's a negative and negative, but it's really a negative pi over 4. So how do we describe this? Shift left by pi over 4. Yeah. So we can shift left by pi over 4. And then we know it's left because it's negative. Okay. This one. Now this is a cos function. Okay, so it doesn't have to be always a sine function, cos function too. So this is going to be pi over 6. And what would this be? Shift to the right by pi by 6. Is everybody okay so far? And then the last but not the least, cos of x plus pi is going to be negative pi. And just to kind of remind ourselves, y is equals to cos times x minus negative pi. Negative pi. So that's going to be shift to the left by pi. Okay. Now that was not so bad for us, right? Because we've seen that in grade 11. We've seen that in a couple of chapters ago when we talk about transformations. So that's not so bad. Let's take a look at this one. Vertical shift. Okay, so what indicates a vertical shift? So from the general equation of a sinusoidal function, or even if the cosine function, a sine b x minus c plus d. And the parameter d, the d value, controls the vertical shift, and that tells us if it's going to be positive, if it's a plus d, it's going to be shifted up, and if it's a negative d, and it's going to be shifted down. So that one's pretty easy, right? So, any questions about these things? No? Okay. So, I'll be right back. started on one side and I just stopped. Thank you. Okay. For now, what we're gonna do is you're gonna be given the function, right? So here's a function here, and here's a function right there. And for now, okay, because we're just learning these things, we're gonna take a look at some characteristics. Did everybody get one? Yeah, okay, thank you. So let's take a look at this one. Now, this one, what kind of transformation do you think it is that happened here? Just, okay, don't look at the graph yet, just look at the equation. 2 sine x plus 1. Describe it. Vertical what? Shift, okay. What tells you, which part of this tells you a vertical shift? Plus 1, right, okay. Yeah, that's right, yeah. So there's actually 2 kinds of transformation that happen in here. So I'll just write it over here. Y is equals to 2 sine brackets x plus 1. So this one tells us, that our graph has a vertical stretch. Okay. Apparently I can't spell stretch. Okay, vertical stretch by a factor of 2. Factor 2, and then, yeah, so you were right. There's also a vertical translation, or vertical shift, that's the same thing. Shift by up 1, right? Up 1. So I'm gonna get my ruler so it's actually clear. And this actually brings everything together. Let's see. Where is the median line? It's a median line is at 1, and that's the D value. The D value is 1. So D value is 1. So the median is 1. What's the maximum? Maximum is 3. Okay, 3. What's the minimum? -1. What's the amplitude?
2.
Okay, now let's revisit this. The word amplitude is from median, from the middle to the maximum, or from the middle to the minimum. Okay, so if I measure this piece, A is what? 2. Yeah, 2. We see that, right? Because it's 1 and then you go up to 2, so that's 1 and up to 3. So amplitude is 2. Where else can you see amplitude of 2? The A value. So amplitude is also the A value, which is 2. Okay, so you can figure out the amplitude by looking at the graph, counting from median up, median to maximum, or median to minimum. If we're given the equation, the function, we can see the A values are amplitude. It's kind of nice how it kind of amplitude A amplitude, right? That's kind of nice. Now, is there another way to figure out the amplitude?
Go from the middle to, take the middle between the maximum. So
Yeah, so you can take this and then this, yeah? Okay, or, okay, let's go back over here. Amplitude. So there's 3 ways you could actually do amplitude. From the equation, from the graph, you can count, or if you know the maximum and minimum. Okay, so let's see here. So we already know amplitude is 2. So A is max minus min divided by 2. We know max is 3 minus, okay, I gotta be careful here, minus -1 divided by 2. So A must be, so 3 minus -1 divided by 2, so it's 4 divided by 2 is 2. Okay, so there's many ways depending on what's given to you. If you're just given the graph, yeah, you can figure out the amplitude by counting or by using this formula. Okay. If you're given the formula, the function, you can figure it out from there. Okay. Here's the other thing too. What's the range?
-1 to 3.
-1 to
3.
+3. -1 to +3.
So it's always just your min and max.
Yeah, so min to max. Yeah. Min to max. Okay. Can you think of a way to figure out the min and max just by looking at the equation? How? 2, okay, so you're in the middle and then you're gonna go an amplitude of 2, so 2, 1 plus 2 will give you the maximum, and then what about the -1? 1, so this is the 1, and then you went down, that's your minimum, down to -2, down by -2, so you're down at -1. That's good. What about period?
2 pi.
Okay, 2 pi? 2 pi. So does it, this is the whole cycle, right? So from 0 to 2 pi. From 0 to 2 pi. So 0 to 2 pi. So that's how you could read it from here. But what about from the equation? Yeah. So the b here, b is equals to 1. Is everybody okay? So if the period is 2 pi over b, so period is 2 pi over 1, which is 2 pi. So there's two ways of figuring that out, looking at the graph or looking at the equation to figure out the period. Yeah, you're okay? Now this one is a little more challenging because there's like, how many transformations are in here? Do you know?
1, 2, 3, 4.
4? 4? Yes. Okay. Let's see if we can name all the transformation. It sounds like a game show. Name that transformation. So y is equals to negative cos brackets 2 x minus pi halves brackets 3. Okay.
Plus 2.
Oh, forgot the plus 3. There you go. So what's a transfer? Name one transformation.
There's a vertical reflection.
A vertical reflection. Okay, vertical reflection. Right? What's the amplitude for this?
1.
1. A is 1. The amplitude is the absolute value of A. Yeah, so yeah. So even though it's negative 1, it's still 1. Okay, so a different person now. Different people. Horizontal. Okay, compression. Okay, compression. Horizontal by what? A half, right? A half. Yeah. 1 over b. Okay. Good. Good. Another person. Shift to the right by half. Okay. Shift right by pi half. Yeah. Another one. Yeah, vertical shift up 3. Awesome. Yeah. Okay, so that's a lot of transformation in one. Okay, so where's the median line? Where's the median? Where do you think the middle is? Okay. Can you tell?
3.
3? Okay, so the median, you can see that's 3, right? From the equation, it's 3. Can you see that it's 3 on the graph?
Yes.
Yeah, you can see that?
Yep.
Okay, so if this
Knowing
is
what the cos graph looks like, do you see the 1 period there, or the 1 lambda? So you know where the median is?
okay, lambda, lambda is actually the 1 wavelength.
Yeah. Wouldn't that be what you're
yeah.
calling a period?
That's basically it. Lambda is the right physics word for the period. Yeah. Yes, sirree. Okay, so this is how, I might as well show it to you. I can see that my graph fluctuates between 2 and 4. The median has to be in the middle between 2 and 4, correct? Yeah, that's what median is about. It's in the middle. It's the middle between minimum and maximum. So sometimes what I do is I draw my line where minimum is. I draw my line where the maximum is. And I can see already that, hey, the middle is 3. You see that? Median is 3. What's the maximum? Oh, that's easy. 4. What's the minimum? 2. What's the amplitude? It's going to be 1. Right? And, okay, remember we said earlier, it's positive 1. Okay? Because it's max minus min divided by 2. Max is 4 minus 2 over 2. It's positive 1. Yeah, it's going to be positive all the time. Even though it says negative, right? The negative just tells us it's reflected over the x-axis. What's the range? 2 to 4. Inclusive. 2 to 4. And what's the period? Okay. So period, sometimes it's hard to read the period, right? So the period we can see is from maximum to next maximum, minimum to next minimum, or median to the next median. Okay, not this next median. So if you're starting here, then your next median would be here. But what's the other way of doing that? Period is equals to 2 pi over b. And we know b is what? 2. Our b value is 2. So it's 2 pi over 2. So it's going to be pi. So instead of 2 pi, are we convinced that it got compressed? Instead of the period of being 2 pi, now it's now compressed to just the pi. So, one sec. What do you think? That's okay? So going through that activity, it's kind of already kind of prepping us. This is what you're gonna see later on, starting on Monday. Monday, you're gonna be given the function. Can you graph it? We have strategy for that. Next time, here's a graph. What do you think I could ask you?
Equation.
Give the equation. Right? Here, it's kind of nice because everything is given. Okay, so that's that. In terms of our notes for today, I think that's basically what we're going to be working on. And then we are so fortunate to have lots and lots of time on a Friday, nice Friday afternoon to do some work now, because some of you work over the weekend. So we can take this time now to do as much as we can now, so we don't have to do it over the weekend. Yes? Okay, sure.
When do we expect to test?